Very good afternoon, students. Good afternoon to all of you. Good afternoon, Ganesh, Suraj, Rahul, and Agastri. How are you all? Yesterday, I couldn't see Nagashri and Ganesh, Suraj, Rahul in the class. Did you all attend it yesterday? You did not come for yesterday's class, right? What happened? Okay, so before moving on to the session, I'm launching a poll. Just let me know if I'm visible and audible to all of you or not. Can you able to see me? Am I audible? Okay. Okay. Very good. Fine. So now let's go into the session. Oh, for Nagashri, yesterday power was not there. Okay, okay, my dear, no problem. So try to follow the class, okay? So ask from your friends that what I have taught yesterday, and yesterday we have discussed the last few topics of coordination compounds. So you can get it from your friends, or you can or look into the class from the YouTube, okay? It is there. Recorded class is there in the YouTube. So now today we are going into the new chapter, which is haloalkanes and haloarenes. So this is the first in organic chemistry lesson of class 12. Okay. So in class 11, we have two lessons. One is basic concepts of organic chemistry and the other one is hydrocarbons. Now in the 12th standard, this is the first lesson from the organic chemistry part. So now let's go into the lesson. Coming to the introduction. What are haloalkanes and haloarenes? Any idea? Do you have any idea? What is a haloarene or what is an haloalkane? Do any of you have any idea about this? You all might be aware of alkanes, right? Yes or no? Alkanes are the hydrocarbons with carbon-carbon single bond. And halo means halogens, right? So it is something related to that. And coming to haloarene also, arene means aromatic carbon. Arenes are nothing but aromatic hydrocarbon. Very good, Ganesh. And if the halogen is attached to an aromatic carbon, it is called as haloarene. So, to an aliphatic or aromatic hydrocarbons, aliphatic means the alkanes part only. Okay. So, to the aliphatic and aromatic hydrocarbon, if we remove one hydrogen and if we add one halogen to that aliphatic or aromatic hydrocarbon, we get an haloalkane or haloarene. Okay. So usually halogens are represented by the letter X. Okay. Halogens are fluorine, chlorine, bromine, and iodine. Okay. So what you have to do? You have to take an aliphatic hydrocarbon, alkane, remove one hydrogen and add one halogen. You will get haloalkane. In the same way, to an aromatic system, remove the hydrogen and add halogen. You will get haloarene. Okay. So to be more specific about the aliphatic hydrocarbons, so I have removed one hydrogen and I have added one halogen and it leads to the formation of haloalkane. Haloalkanes are otherwise called as alkyl halides. Okay, both are same only. Alkyl halide is the common name. Haloalkane is the IUPAC name. That's it. Now let me give you one example. So here I have CH4. Okay. So it is called as methane. So in methane I have four hydrogen and one carbon, right? So I'm going to remove the red color hydrogen which is present over there. And I'm going to replace it with the halogen chlorine. So it will lead to the formation of methyl chloride. Okay. So there is some issue here. Actually, here we have a carbon. Here we have a carbon and here chlorine, hydrogen, hydrogen and hydrogen. Okay. So what do we have here? The hydrogen of methane is replaced by chlorine, which is a halogen. So it is called as methyl chloride, alkyl halide, okay, or haloalkane. Got it? Now, in the same way, for aromatic hydrocarbon also, if we remove a hydrogen and add halogen, we will get haloarine. They are also called as aryl halides. Haloarenes are otherwise called as aryl halides. So, let me take an aromatic system, which is a benzene. So, in benzene, I have 6 hydrogen, okay, 6 carbon and 6 hydrogen. Remove one hydrogen and replace it with one halogen. And here the halogen that I have took is bromine. And if I replace, I will get an haloarine, okay, or otherwise called as aryl halides. So is this clear? This is the introduction to haloalkane and haloarine. Now, why haloalkanes and haloarine? Why do we need to prepare the haloalkane and haloarine? So it should have some application in the day-to-day life, right? So by preparing this haloalkane and haloarine, we have the wide applications in industry as well as in day-to-day life. For example, if I take the first example I'm going to take is polyvinyl chloride, the PVC pipes. So we are all using pipes in our homes, right? So it is an haloalkane. Polyvinyl chloride is a haloalkane. And next coming to one more compound, chloroform. So mostly we will use chloroform to preserve the specimens. Okay. So chloroform is a haloalkane. Next, if you see the pan, so the black colored coating is there in the pan, right? So it is actually called as Teflon. Okay, Teflon is an haloalkane. And one more thing. So in the day-to-day life, we use DDT, right? DDT is a pesticide. So it is dichloro, diphenyl, trichloroethane. Dichloro, diphenyl, trichloroethane. So which is a haloalkane. Okay, so these are some of the very common examples which we use in our day-to-day life. Okay, now some more are also there. So this is a compound which is named as chloramphenicol. So this chloramphenicol is used in the treatment of typhoid fever. This compound will be there in the medicine. Okay, in the medicine, chloramphenicol will be present in the tablet and that is used for the treatment of typhoid fever. And this compound is a haloalkane. So we have the halogen, right, attached to the aliphatic system. So it is a haloalkane. And next here, chloroquine. Chloroquine. So it has one halogen attached to aromatic system. So it is an haloarine. So it is used in the treatment of malaria. Chloroquine is used in the treatment of malaria. Not only these two, our body also produces iodine containing hormone called thyroxine. Okay, iodine containing hormone called thyroxine, the deficiency of which causes a disease called goiter. Okay, so thyroxine is also a haloalkane. Got it? So this is why, this is how, and this is why we are preparing the haloalkanes and haloarenes from the alkanes and aromatic hydrocarbons. Got it? So this is the use, this is the need for preparation of the haloalkane and haloarine. Now let's move on to the main topics of this lesson. So do you have any doubts from the introduction part and the application part of haloalkanes and haloarine, students? Do you have any doubt? Is everything clear? Shall I go for the next slide? You want to ask anything from this? So all of you should study the name of the chemical and the treatment purpose for which treatment it is getting used. Okay? Say yes or no so that I can move on to the next slide. Why are you all keeping quiet? Huh? Ganesh, Suraj, Sirisha, Rahul, Priyanka, Disha, Nagashri. So every time I have to call your names or what? Okay. Thank you, Ganesh. So now let's go into the next topic, which is classification, nomenclature, and nature of carbon-halogen bond. Okay. So firstly, classification of halogen-containing compound, then nomenclature, then nature. So the nature of CX bond. So these are the learning objectives under this first topic of this lesson. Coming to the first topic, which is classification of halogen-containing compound. So first of all, we are going to classify the compounds on the basis of number of halogens present. Okay, it is actually very easy. So if only one halogen is present in the compound, then we call that as monohalogen. Okay, and if two halogens are there, then it is called as dihalogen. If more than two are there, then it is called as a polyhalogen compound. Okay, so I'll give you some examples. You see, so we have C2H5X, and in this compound we have only one halogen, monohaloalkane. Okay, if I have two halogen in one compound, it is dihaloalkane. Then the third one is trihaloalkane. Okay, so these are the three classifications, three divisions under the classification on the basis of number of halogen. Okay. So is it clear to all of you? Now in the same way, aromatic aromatic hydrocarbons, the aryl halides are also classified. So if I have only one halogen in the benzene ring, it is monohaloarene. If there are two, dihaloarene. If there are three, it is called as trihaloarene. Okay. So it's very easy. Based on the number of halogens, you can classify this accordingly. Okay. Now let's see one by one. So let me take the monohalogen compounds first. So I am taking monohalogen compounds. So this monohalogen compounds is getting classified into two. Okay. So one is on the basis of sp3 hybridized carbon to which the halogen is attached. Okay. The second is halogen attached with sp2 hybridized carbon. So let's study about the first division in the first part, and then we will go on to the sp2 hybridized system. So coming to the halogen attached with sp3 carbon, it is classified into alkyl halides. Alkyl halide means the halogen attached with the alkyl group. For example, CH3X. So here CH3 is the alkyl part. CH3 is the alkyl part, and this is called as methyl. This alkyl is called as methyl. Since we have only one carbon, it is called as methyl. And if you see, the halogen is attached to the methyl carbon, which is sp3 hybridized. So how to find out the hybridization? By looking into the carbon. If the carbon has double bond, then it is sp2. If it has only single bond, then it is sp3. So here the halogen is attached to the carbon which has only single bond, around it. So it is an sp3 hybridized carbon. Okay. Just by looking into the screen, you should not say that, ma'am, halogen is attached with hydrogen. How we are saying that it is attached with carbon? Okay, while writing, we will write CH3X, but practically, this is the structure, exact real structure of CH3X. Okay, halogen is bonded with carbon only, not with hydrogen. Okay, next. Secondly, it is called as allyl halides. Allyl halide means there will be three carbons. There will be three carbons. Okay. And between carbon 1 and 2, we will have a double bond. And the third carbon will be attached to the halogen. So if you are having three carbon with the double bond, single bond and single bond, then it is called as an allylic system. Okay. So here is the picture. You see, here we have two carbon and here we have one carbon, double bond, single bond, and here we have one bond, single bond. This is that bond. Okay. Single bond. So the halogen is attached to the single bond, which is sp3 hybridized carbon. Okay. And that carbon is attached with the sp2. We should not see that part. Okay. So this carbon is sp2. We should not see that carbon. We have to see the carbon which is attached with halogen. Okay. So since this carbon is sp3 hybridized, it is an allylic carbon. Okay. It is an allylic carbon. So allylic halides are the second classification under sp3 hybridized system. Then coming to the third classification, it is benzylic halide. What is meant by benzylic? If I have C6H5, C6H5CH2, then this group is called as benzylic group. This group is called as benzylic group. Okay. So if I have an halogen attached to this CH2, it is called as benzylic halide. Okay. So this part is benzyl part. This part is called as a benzyl part. And this is the halogen which is attached to the benzyl part. Okay. And if you look into this carbon, it is sp3 hybridized because all the bonds are single bonds, right? This is a single bond. Okay, and here also we have a single bond and there are two single bond with the hydrogen also. So it is sp3, but this carbon, this one is sp2. Since it is doubly bonded carbon, it is sp2. We should not see that carbon. We have to see only the sp3 hybridized carbon. So that is actually called as benzylic carbon. Okay, sp3 hybridized carbon is called as benzylic carbon. So these are the three classifications under the sp3 hybridized carbon system, okay, to which the halogen is attached. So any doubt from this three? Is everything clear? This part is very important, okay, because they have asked many questions in the previous years from this classification part, which is actually easy but important. Okay. So any doubt for anyone? Everything clear under sp3 hybridized system? If it is clear, type yes in the chat box. If it is not clear, ask your doubt. So I'm here to clear your doubts only, right? Students, everything all right? Any doubt? Shall we go to the halogen attached with the sp2 hybridized system? Okay. Okay, Sirisha. Good. So now let's move on to the second type. So under this sp2 carbon, we have two types. One is vinylic halide. So allylic means what I have said, there should be three carbon with a double bond, single bond manner. Vinylic means there should be two carbon. There should be only two carbon. Carbon, double bond carbon, and that will be directly attached to the halogen. So this is a carbon, double bonded carbon that is directly attached to the halogen. And the halogen attached carbon is having the double bond. Halogen attached carbon is having the double bond. So if the carbon is having double bond, then it is sp2 hybridized, right? So this is the sp2 hybridized carbon. Okay, and I'll show one more example. So here is another example. So in the ring system, you see, it is also a vinylic halide only because halogen is there. It is attached with a double bonded carbon and it is having one more double carbon to it. Okay. So this is the vinylic part. This is the vinylic part and the halogen attached carbon is sp2 hybridized. Okay. So both of them are vinyl halides. Then the second classification is aryl halide, which is nothing but the haloarene. Okay. Haloarene. So halogen attached carbon is sp2 because it is having double bond attached to it. Clear? So this is all about the classification of compounds. On the basis of number of halogen, we have classified it into 3, and among those 3, we have took the first classification, which is monohalogen compound, and in that monohalogen we have 2 classification. One is with sp3, the other one is with sp2, and under sp3 we have 3 types. Under the sp2 we have studied 2 types. Everything clear so far for all of you? Shall we go for the nomenclature? Students say yes or no. Is it clear? Bishan, Karima Begum, Nagashri. Yes? Okay, Rahul. Good. Okay. So now coming to the nomenclature of halogen containing compounds. Nomenclature of halogen containing compounds. So here we have 2 different names. Okay, for naming an organic compound, we have 2 different types of naming. One is common name and the other one is IUPAC name. So here coming to the haloalkane, the common name, the general common name is alkyl halide. Okay. And the IUPAC name is haloalkane. Okay. Common name is alkyl halide. IUPAC name is haloalkane. Now let's see the common names for some of the compounds. Okay. So first I am going to take CH3F. So what we have to do in the common name? You have to use alkyl halide. So what is the name of the alkyl group here? CH3 is the alkyl group. So if I have only one carbon, it is called as methyl. Alkyl is methyl. And who is the halogen? Fluoride. So what is the name of this compound? Methyl fluoride. Okay, alkyl halide. Methyl fluoride. Okay, so I'll show you one more compound. You guys try to name this. So here, this is the alkyl part. In this alkyl part, we have 2 carbon. If I have 2 carbon, what is the name of this alkyl group? It is ethyl, right? If I have 2 carbon, it is called as ethyl. And this is the chloride. So what is the name of this compound? Can anyone tell me the name of this compound? Ethyl chloride. Okay, the name of the compound is ethyl chloride. Okay, and coming to the third compound. So here we have 3 carbons. 3 carbons in a straight chain manner. So 3 carbon means what is the name of the alkyl group? 1 carbon means methyl. 2 carbon means ethyl. 3 carbon means it is propyl. So in the propyl case, we have 2 propyl, right? One is N-propyl and the other one is isopropyl. N-propyl means normal propyl. Normal means all the 3 carbons will be there in the straight chain manner. So it is N-propyl. Okay. So this propyl is actually called as N-propyl and the halogen is bromine. So it is N-propyl bromide. It is called as N-propyl bromide. Okay. So if I have the 3 carbons arranged in this manner. So here all the 3 are not in the straight chain. I mean the halogen is not attached to the straight chain system. It is attached with the branch. Halogen here is iodine and it is attached to the second carbon of this 3 carbon system. So it is actually called as isopropyl. It is called as isopropyl. And since the halogen is iodine, it is isopropyl iodide. Okay, isopropyl iodide. And if I have 5 carbons arranged in this manner, so this part is called as neopentyl. Okay, if you do not know the structure before, try to learn from today onwards. Okay, if 5 carbons are arranged like this, it is neopentyl. Since 5 are there, it is pent. Okay, neopentyl chloride. Neopentyl chloride. Is it clear for all of you? In all the cases, we have used the common naming alkyl halide. Okay. Is it clear, students, for all of you? Any doubt from this? Nomenclature is again an important part. So all the topics in the organic chemistry, they are very, very important. Okay, so more number of questions will come from the organic chemistry because initially we had 30 lessons. I have already told you, right? Initially we had 30 lessons, but from the last 2 years onwards, 10 lessons from the chemistry have got deleted. Okay, but in those 10 lessons, not even a single organic chemistry lesson got deleted. Okay, so all the organic chemistry part is very important for both JEE and NEET. So you should concentrate more on organic chemistry because the straightforward questions will come from organic chemistry NCERT book. Okay. So the nomenclature is clear to all of you. The common naming is clear to all of you. Shall we go for the IUPAC naming? Yes or no? Only one has replied. Only Karima Begum has replied. What about others? Shall we go for the IUPAC naming of this alkyl halide? Yes? Okay. So coming to the IUPAC naming of the same 5 compounds. Yeah. Okay. And here in the IUPAC naming, we have to follow some rules. So what is the full form of IUPAC? Can anyone tell me the full form of IUPAC? You might have already studied in your 11th class, right? In some basic concepts of organic chemistry lesson. What is the full form of IUPAC? It is a general question I am asking you. Can you tell me? Can anyone give a try? Full form of IUPAC? International Union of Pure and Applied Chemistry. Okay. International Union of Pure and Applied Chemistry. So these people, they had some set of rules to name the compound which we are discovering every day. Okay, so just like that, we cannot give some names for the compounds which we are discovering. So we have to follow a set of rules. So according to the IUPAC nomenclature rules, we are naming the compounds. We are naming the new compounds which we are synthesizing in the lab in the everyday. Okay. So here for naming the alkyl halides, we have to use a prefix. And the prefix is halo. Okay. Prefix used here is halo. So let me take the same compound CH3F. So who is the halogen here? Fluorine is the halogen. So fluoro. So prefix should be fluoro. So fluoro, and here we have only one carbon. So it is fluoro methane. Okay. Halo alkane. Haloalkane is the IUPAC naming system. Okay. This is called as chloroethane. If we have 2 carbon, it is ethane, right? So it is called as chloroethane. So can you guys try for this third compound? If we have more than 2 carbon, we have to start numbering the carbon atoms. Okay. And while numbering, you have to have some points in your mind. The halogen attached carbon should get number 1. Okay. And then 2 and then 3. So here it is 1-bromopropane. This is called as 1-bromopropane. Since I have 3 carbon, it is called as propane. Here also I have 3 carbon. Okay. And here the numbering can be done in both the ways, left to right or right to left, because both will give you the number 2 of the carbon to which the iodine is attached. So you can number from left to right or right to left. I am going to use the right to left numbering. So I am numbering like this, 1, 2, 3. And to the second carbon, iodine is attached. So what will be the name of this compound? What will be the name of this compound? Please try and let me know the answer in the chat box. What is the name of this compound? Let me see who is going to give me the correct answer. What is IUPAC name of this compound, my dear students? Two iodo propane. Very good. Two iodine. To the second carbon, iodine is attached, right? Very good. So it is called as two iodopropane. Ganesh, it is not propene. It is propane. We have only single bonds, right? So it is propane. Sirisha, why you have gone for one iodo? It is two iodo. Okay. To the second carbon, iodine is attached, no? So fine. What about this? What is IUPAC name of the last compound? We have to first look into the parent chain, right? So the first rule to be followed is if we have some branches, we have to find out the parent chain first of all. So which is the parent chain? The chlorine attached chain is the parent chain. So then now I have to number the carbons which is there in the parent chain. 1, 2, 3 like this. And now this CH3 and this CH3 are the branches. They are all considered to be a branch. Okay, Ganesh, no problem. No problem. I can understand. Okay. So 2CH3 are the branch and chlorine is also a substituent. So we have two substituents. One is chloro and the other two are methyl. So if we have more than one substituent, we have to follow the alphabetical order, right? So among M and M, M and C, which comes first in the alphabet? C. So you have to start naming the compound with C. So it is 1 chloro, 2,2 dimethyl propane. So to the first carbon, chlorine is attached. To the second carbon, 2 methyl are attached. So we have to represent it by using comma 2, 2 dimethyl, and we have 3 carbons in the parent chain. So it is called as propane. Is it clear to all of you? 1 chloro, 2, 2 dimethyl, propane. Is it clear for all of you students? Do you feel any difficulty here? You want me to explain any of the compounds shown on the slide? Yes? Everything clear or you have doubts, students? Shall I go for the next slide? The IUPAC naming clear to all of you? Okay. So now we'll go for the aromatic system. Okay, we will go for aromatic system. So here is the aromatic haloarene. What is the name of this compound? Haloalkane is the IUPAC skeletal structure, skeletal name. Haloarene is the general name we have to follow for naming the aromatic system. So the halogen is bromo and we have a benzene. So it is called as bromobenzene. Okay, if I have 2 bromo, then I have to start numbering. So number 1 has to be given for this bromine and number 2 for the second bromine. So it is 1, 2 dibromobenzene. Okay, or ortho-dibromobenzene. Ortho-dibromobenzene is the common name. 1, 2 dibromobenzene is the IUPAC name. Okay, because only in the IUPAC nomenclature we will use the numbers. In common name, we use ortho, meta and para. Okay, so if 2 bromines are adjacent to each other, then it is called as ortho. Now here in this compound you see 2 bromines are opposite to each other. If I number, I will get the number 1 and 4. Okay, 1, 4 dibromobenzene. But since 2 bromines are opposite to each other, it is called as para. So it is para dibromobenzene. Common name is para dibromobenzene and IUPAC name is 1, 4 dibromobenzene. Okay. So if the 2 bromines are alternative to each other, what will be the name? If the 2 bromines are alternative like this. If I have two bromines like this, what will be the name? Can anyone give me the IUPAC name first, and then give me the common name for this compound? If they are adjacent to each other, we are calling it as ortho. If it is opposite to each other, we are calling it as meta. If it is alternate with each other, then what is the name of this compound? The common name and IUPAC name? Can you try for it? If you number, how will you number? You have to start from here. 1, 2, 3, 4, 5, 6. Okay, numbering has to be done for carbon. And to the first carbon and the third carbon, we have bromine. So the IUPAC name will be, yeah, very good, Rahul. It is 1,3 dibromobenzene. IUPAC naming is 1,3 dibromobenzene. What is the common name? Yeah, meta-dibromobenzene. Very good, Bishan. It is meta-dibromobenzene. Okay. Meta-dibromobenzene. So, adjacent means ortho, alternate means meta, opposite means para. 1,2, 1,3, 1,4. Okay. It's very easy. Now, I'll go for one more compound. CH2 double bond CH single bond Cl. It is actually the vinylic system, right? So we have a double bond and it is directly attached with the chloride. Okay, Cc. So it is a vinyl chloride. The common name is vinyl chloride. But what about the IUPAC name? CH2 double bond CH2 is called as ethene. CH2 double bond CH2 is called as ethene. Now in this ethene, one of the hydrogen is replaced by chlorine. So what is the name? Chloroethene. The name will be chloroethene. Okay. And the common name is vinyl chloride. Okay. Now I'll go for one more compound. Here I have 3 carbons, which is actually an allylic system. If I have more than 2 carbon, then I have to number it, right? So how will I number? From left to right or right to left? Should I give importance first preference to the double bond or to the bromine? What is your answer? The first preference has to be given for the double bond. So the numbering has to be done in such a way that the double bonded carbon should get the first preference. Okay, and then only the bromine attached to carbon. So 1, 2, 3, left to right numbering is the correct way of numbering. Now the name is 3-bromo-propene. 3-bromo-propene. Okay, 3 carbon containing with 1 double bond. So it is propene. And this is an allylic system, double bond, single bond and single bond with bromine. So it is an allylic carbon. So allyl bromide is the common name. Okay. And CHCl3. So it is trichloromethane. Since we have only 1 carbon, it is methane. And 3 chlorines are attached. So it is trichloromethane. And the common name is chloroform. Common name is chloroform. Is it clear for all of you? Is it clear for all of you? Any doubt? So this is how we have to go for the nomenclature. Common name and IUPAC name for the compounds which has double bond. Okay. Any doubt? Shall I go for the next slide? Yes. So in the next slide, I have got 3 questions for you. Okay. So you need to find out the IUPAC names of these 3 compounds before coming to the next class. Will you all do it? Just take the screenshot of this. Take the screenshot of this. I hope all of you are having your devices with you. So all of you take the screenshot of these 3 questions and write the IUPAC name before coming to the next class. I will ask. You should be able to tell. Okay. Yes? Have you all taken the screenshot or the snap of this? Say yes or no, students, so that we can go for the next. Oh. Shall I go for the next? Have you all noted this in your notebook? Okay, I'll go for the next slide. Give me a moment. Yeah. So this is the next question. This is the next question for you. So you need to write the structures from the name. So initially I gave you the structure and you have written you have to write the name of the compound, and here the names are given. You need to write the structure and compound. Okay. So please do these two exercises as your homework before coming for the next session on Monday. Okay. Now I will go for the next topic. Now I'll go for the next topic. What is the last topic of this today's class? Nature of carbon halogen bond. Okay. Nature of carbon halogen bond. So can you all able to see the screen? Can you all able to see the screen? It is nature of carbon halogen bond in halogen containing compounds. So now coming to the nature of carbon halogen bond. So here we have a carbon and the halogen. Who is more electronegative among these two? Halogen or carbon? Who is more electronegative? Electronegativity means the tendency of attracting the shared pair of electrons towards itself, right? So which atom will be more electronegative? Halogen or carbon? Yeah, very good. It is halogen. So halogen is more electronegative. So what it will do? It will attract the shared pair of electrons towards itself. So since the halogen is gaining the electron from carbon, it will get the partially negative charge and the carbon will get the partially positive charge. Okay. Now what has happened to this bond? The bond has been separated. It has a dipole. The charge has been separated into plus and minus. So we have two poles, negative pole and positive pole. So the bond is called as polar bond. It is called as the polar molecule. So the nature of the carbon halogen bond is polar in nature. Okay, it is a polar bond. Now coming to the halogen atom size. So which halogen will be smaller among fluorine, chlorine, bromine and iodine? Fluorine or iodine? What is the order of size of halogen atom? Very good. Fluorine is smaller in size. Okay, next comes chlorine and after that bromine and last one will be iodine. Iodine is bigger in size. So if the size follows this order, what will be the bond length of carbon and halogen? So this is CF, this is CCl bond, this is CBr bond length and this is CI bond length. So which bond length will be more? Carbon fluorine or carbon iodine? Since the size of the iodine is bigger, carbon iodine bond length will be bigger. Okay, the bond length of carbon iodine will be more. Okay, so if this is the case, what about the bond strength? Bond length and bond strength are inversely proportional. Okay, bond length and bond strength are inversely proportional to each other. Since the bond length of carbon and iodine is more, bond strength of carbon and iodine will be very, very less. Okay? They are inversely proportional. If the two atoms are very closer to each other, then the strength of that bond will be more, no? So carbon fluorine bond is strong compared to the carbon chlorine, then comes bromine and then iodine. Okay. So all the three orders, especially the last two bond length and bond strength order is very, very important because they will ask question like bond length order for the, so like that they will ask. Okay. So you should be able to answer for such type of question. Got it? So any doubt for anyone? Is everything clear? Is everything clear for all of you? So now I will go for the summary. So let me summarize the concepts that we have studied. So firstly, we have studied the classification of halogen containing compounds. So in the classification, we had studied three: monohalogen, dihalogen, and polyhalogen. And monohalogen was classified into two: sp3, sp2. Under sp3, three types, and under sp2, two types. Okay. Alkyl halide, allyl halide, benzyl halide, and under sp2, vinyl halide and aryl halide. Next, in the nomenclature part, there were two things. One is common name and the other one is IUPAC name. Okay, in the common name, we use alkyl halide, and in the IUPAC name, we used haloalkane. Okay. The same way for aromatic system also, aryl halide and haloarene. Okay. These are all about the nomenclature. Then lastly, we have studied some concepts, right? Regarding the nature of CX bond. So the carbon halogen bond is, this bond is polar in nature, and the bond length and the bond strength order is very important. So these are the three topics which we have covered in today's session. So do you have any doubt from these three concepts, from the classification, nomenclature, and the nature of CX bond? Any doubt? Any doubt for anyone? No doubt for Rahul. Okay. So fine. So I have launched a poll for class feedback. You can give your answers over there in the poll, and then you can get ready for your next class. Okay. Thank you so much for listening to lecture, students. Meet you all with a new uh, concept from this lesson in the next session. Till then, take care. Bye-bye. Okay. So I want all of you to answer the questions which is given in the poll. Kindly do it and go for the next class. Thank you.